Okay, in this tutorial we're going to be looking at partial fractions. Okay, so if you've been working along and watching some of the videos, I've been working through the Maths Quest textbook like we have been, then you'll probably come across some questions in 1.4 with graphing that you find quite difficult to find, things like the oblique asymptote. Okay, we use partial fractions to split up some of our functions, okay, and this is how we do it. Okay, so to create partial fractions, so this is a process used to split the expression p of x over q of x, where q of x is a quadratic. So the first step is if p of x is greater than or equal to the degree of q of x, okay, then we divide q of x into p of x first. So that's saying that this could be x cubed and that's x squared, so we've got to do a division there first. Okay, the next step is to factorize q. Step 3 is to set up this equation here, where we've got the original equation, and that's equal to a over r of x plus b over s of x. And r of x and s of x are just factors of q of x, okay, and they're usually linear. So factorize this. This is one factor, that's the other factor. Okay, and we'll put in these values a and b. Okay, what we do is we express the right hand side the same form as the left hand side with the same denominators. So basically what we're doing here is like exactly what we would do if we were going to add these two fractions together and they've got a different denominator. Okay, we multiply across here, so we do our cross multiplication, we do a times s of x and r times b of x, sorry, r of x times b, and then we multiply our denominators together, okay, which of course gets us back to q of x. So we end up here with our as of x plus br of x over q of x. Okay, at this stage what we do is we just equate the numerators. So forget the denominators because they're the same anyway. Okay, so we just equate our numerators. Okay, and then what we do is we solve for a and b by substituting in values of x that will cause either this bit to become 0 or this part to become 0. So often, like s of x might be, I don't know, x take 4. Okay, so what you do is sub in x equals 4, okay, into this equation, both sides. Okay, this term would drop out. Okay, this would equal 0, this would equal something, this would equal something, and from there we can work out b. Sub in something that makes this equal 0, then we can work out a. Okay, so once we've got our a and b values, then we sub them back in to our partial fraction. Okay, and we're done. Okay, so there's a number of different cases to this, and some do slightly deviate away from these steps, but usually not by very much. Okay, so we'll go through the 4 cases that we have. Okay, so case 1, this is where we have a factorised denominator. So we're saying that if f of x, g of x and h of x are linear functions, then f of x over g of x times h of x will equal a over g of x plus b over h of x. So what we can do, okay, we're going to be looking at expressing x take 5 over x plus 3, x take 1. Okay, so what we're going to do is we're going to split this up now into this form. Okay, so we're going to say that this is equal to a over this factor, our x plus 3, plus b over x take 1. Okay, so just split up and we've got our a and b values in now. Now we need to do our cross multiplication. So we're going to go a times this one, b times this one. Okay, it's still going to be equal to what we had. X plus 3, x take 1 is equal to a outside of x take 1 plus b outside of x plus 3. Okay, and that's all going to be over our x plus 3 times our x take 1. Okay, so we've actually added those two fractions together now. So this is where we just equate the numerators. So we say that x take 5 equal to a outside of x take 1 plus b outside of x plus 3. Okay, now what we do, so we pick values for x here and here, they'll cancel them out. So what we'll do is we'll start off with this one and we'll say, well, let's let x equal 1. Okay, so what happens then? Well, this side, at 1 take 5 is going to give us minus 4 equals, well, 1 take 1 is 0 times a is 0, so that term's gone, that's the whole point. Okay, then here we get between 1 and we get 4, so we get 4b Okay, therefore b equals -1. Okay, what we're going to do now is we'll let x equal -3 because that'll make this term equal 0. So we've got -3 take 5 will give us -8. Okay, and then we have -3 take 1 will give us -4. So we get -4a. And of course, as we said, this term's going to drop out. So we divide that and we end up with a equals 2. Okay, so then we finish it off and say, well, we look back here and go, well, then our partial fraction will be 2 over x plus 3 plus, I should have done plus, sorry, because we'll be plus -1 over our x take 1. So we think of that as our 2 over x plus 3 minus 1 over x take 1. Okay, so that's our first case. Now we're straightforward. We'll flip over now. So we're saying that in case 2, we have a perfect square denominator. So saying if f of x and g of x are linear, then f of x over g of x squared will be a over g of x plus b over g of x squared. Okay, so that's a squared up there. Okay, so we'll show you how to do one like this now. So we want to express 2x take 3 over 4x minus 7 squared as partial fraction. Okay, so again, what we do is we set this one up by using this idea. Okay, that we have a over 4x take 7 plus b over 4x take 7 squared. Okay, so this one's a little bit different. Okay, because then we can say, well, 2x take 3 over 4x minus 7 squared. Well, that's going to be, now, we want to add these fractions together. This denominator is the denominator that we need, so we're not going to do anything to this term. Okay, we're just going to multiply this term, our a term, by our 4x take 7. So we'll go a outside of our 4x minus 7, okay, plus our b that we're not changing, all over our 4x take 7 squared. Okay, so in order to get this the same denominator as that, we're timesing the whole thing by 4x take 7, okay, which means only our a gets changed, our b doesn't. Okay, now into the stage of equating our numerators. Okay, so what we do now is we need to substitute in a value here. Okay, they'll get rid of our a value. Okay, so we need to let x equal 7 over 4. Okay, that'll get rid of this. Okay, so then we get 2 times 7 over 4 minus 3. Okay, we just said this is equal to 0 now, will give us our b value. Okay, so then we keep working through that and will be 7 over 2 minus 3 equals b. Okay, so b is going to equal a half. Okay, so now what we've got to do is we need to sub in another value for x in here, okay, and use our b value. Okay, so for this one, it doesn't matter what we sub in this time. Okay, but always a nice one is subbing in 0. This time we'll let x equal 0. So I can't think of a case off the top of my head where you wouldn't want to make x equal 0 for this. Okay, so when we let x equal 0, well, this side, okay, becomes minus 3. Okay, here, well, that drops out, so we've got a times minus 7, so minus 7a. And we also need to make sure for these ones that we're including our b value that we've just worked out. Okay, so we're getting there. Okay, so we take away our half, okay, which will mean that we're minus 7 on 2 equals minus 7a. Okay, so then we can divide by our minus 7 and we'll also get that a equals a half. Okay, it's not too often that we actually get our a and b value to be the same thing, but in this case it's happened. Okay, so then we're saying, well, our 2x minus 3 over our 4x minus 7 squared, okay, can be written as, we'll get a half over, because remember we're looking at this part, our 4x minus 7 plus a half over our 4x minus 7 squared, okay, which we can say is 1 over 2 times 4x minus 7 plus 1 over 2 side of 4x minus 7 squared. Okay, and we're done for this one. Okay, next one. Okay, we say our denominator is not factorised. Okay, so basically we've just got to factorise our denominator first. So for this one, we want to express minus x take 15 over x squared minus 9. Okay, so what we're going to do is we're going to factorise this first, so we know that that's equal to minus x take 15 over, we've got perfect squares here, so it'll be x plus 3 and x minus 3. Okay, and now we can start setting things up, so say our negative x take 15 over x plus 3, x take 3 is equal to, well, we're going to have our a over our x plus 3 plus b over our x minus 3. Okay, do our cross multiplication. Yeah, we'll just say that this is equal to our a outside of x minus 3 plus b outside of our x plus 3 over our x plus 3, x take 3. Okay, now we can equate our numerators, so we can say we've got negative x take 15 equals a times x take 3 plus b times x plus 3. Okay, now we pick values that are cancelling out our brackets here, so we'll start off by saying let x equal 3. Okay, then we'll have minus 3 take 15. Well, this one will drop out, so then we've got b 3 plus 3, so we'll have minus 18 equals 6b, so b will equal negative 3. Okay, then we're going to let x equal minus 3, so we have double negative here will turn into positive 3 take 15 will give us minus 12. Okay, minus 3 take 3 will be minus 6. Okay, so it'll be minus 6a. And then this one's going to drop out, so then we'll get a equals 2. So then we can finish it off. So we can write minus x take 15 over our x. So I should do our original one, x squared take 9 is equal to 2 over x plus 3 minus 3 over x take 3. Again, you could have written that as take away instead of adding negative 3. So we've got one more case to go. Okay, and one more with example. Okay, so this is where the degree of our numerator is bigger than or equal to the degree of the denominator. Okay, so what we'll do is, there's two worked examples here. I'm going to do the second part of it, okay, which is where we've got 2x cubed minus 5x squared plus 3x plus 7 over x squared minus x minus 2. So what we need to do is we actually need to do this division first. Now we haven't actually probably seen how to do division of polynomials like this. In the past we've always just been dividing perhaps this polynomial here by just a linear factor. Okay, but we can do it by quadratics as well. So what we do is say, well, we've got our x squared minus x minus 2. We've got our 2x cubed minus 5x squared plus 3x plus 7. Okay, and again, we only worry about this first term, and we go, well, how many times does x squared go into 2x cubed? And the answer will be 2x. Okay, multiply back around, so you get 2x cubed take 2x squared plus, no sorry, take 4x, okay, bracket, bracket, take away the line underneath, 2x cubed, take 2x cubed is 0, that's the whole point, negative 5x squared, take negative, so we're going to add on 2x squared will give us negative 3x squared, okay, and we're going to 3x, take negative, that was a negative, remember, that was my mistake, okay, so we're going to be adding it on, so we'll get 7x, plus 7x, then bring down our 7 left over, okay, and we go again, okay, so you keep doing this process until this is a higher degree than this. So we're equal at the moment, so we can keep going. So how many x squared is negative 3x squared? Well, that'll be negative 3. Okay, we multiply back around. Now, in the past when we've done these, when usually we do the division of polynomials, we're going to expect that when we multiply this back through, they'll equal this nicely, we'll take it away, and all equals 0. Okay, but it's not the case with these ones. Okay, so we multiply back through and we'll get negative 3x squared plus 3x plus 6. Get bracket, bracket, take away line underneath. So we get negative 3x squared, take negative 3x squared gives us 0. 7x take 3x will leave us with 4x. And 7 take 6 will leave us with 1. Okay, now this is our remainder. Okay, this is our remainder. So we can think of our answer now being 2x take 3. Okay, and when we express our remainders, okay, we always express it as what our remainder is, okay, over what we're dividing by. So we're going to do that over our x squared minus x minus 2. Okay, so we'll keep going now. So what we need to do is we need to factorise this. So what we're going to do is we're going to ignore this part for a little while and just focus on this. So we're going to factorise the denominator. So we've got 4x plus 1 over x plus 1 x minus 2. Okay, and we're going to say then that that's going to equal a over x plus 1 plus b over x take 2. Okay, now we're going to cross multiply. Okay, so we get our 4x plus 1 over our x plus 1 x take 2. Okay, equals our a times x take 2 plus b times x plus 1 over our x plus 1 x take 2. Okay, equate our numerators. We've got our 4x plus 1 equaling our a x take 2 plus b x plus 1. Okay, pick our values here. So we'll say that we'll let x equal 2. Okay, because that will cancel out this one. So 4 times 2 is 8 plus 1 is 9 equals, 2 plus 1 is 3, so 3b. Therefore our b will equal 3. Okay, we're getting there. Okay, so now we let x equal negative 1 to cancel out this bracket. So 4 times negative 1 is negative 4 plus 1 will give us negative 3. Equals negative 1, take 2 is negative 3, so we get negative 3a. So a will equal 1. Okay, so overall, okay, our answer is 2x take 3, plus, and I'll write that out again, 2x take 3 plus a over, a is 1. Sorry, I'm marking this up on here right at the end. 2x take 3 plus 1 over our x plus 1 plus our b value, which is 3 over our x take 2. Okay, and we're done. Okay, so don't forget this first part that we had. Okay, so if you've been doing some of our graphing type questions, okay, and you've been struggling to work out how they're split up the function and found the equation of our oblique asymptote, that's it there. Okay, so our oblique asymptote, the equation of that, okay, is what we get up here when we do our division. So that's our oblique asymptote. Right? And you'd see that we also have vertical asymptotes at -1 and at 2 as well. Okay, if you're looking at graphing this function. Okay, so hopefully that's enough to get you through. I'll be putting up some questions on my blog as well on this section.